here. So now that you know how to do the center of that stoichiometry island from moles of substance A to moles of substance B, let's go ahead and show you the entire process from start to finish. The one that I'm going to be showing you an example of is mass to moles to moles to mass. Okay, so mass to mass conversion. You could do volume to volume. You could do particles to particles. I'm showing you mass to mass. So when you do that, it basically breaks down to this equation here. The given amount of something times some sort of conversion factor times a mole ratio times another conversion factor. That's going to get you your unknown amount. So here's the sample problem we're going to be doing. Again, we're working with that same equation of nitrogen plus hydrogen yielding ammonia. Calculate the number of grams of ammonia produced by the reaction of 5.4 grams of hydrogen with an excess of nitrogen. And then there's the balanced chemical equation. All right, so let's go ahead and use our stoichiometry island and our problem here to start breaking this down. So again, I've got this the equation or formula, I guess you want to call it, that I've kind of written out up here, but then you also have your stoichiometry island that you're going to need as well. So, given amount, what did the problem give us? It gave us 5.4 grams of hydrogen. What are we trying to find? We're trying to find grams of ammonia. So those are going to be important pieces for you to identify. Some of you may struggle with just figuring out, what did the problem give us? What are we trying to find? So it gave us grams of hydrogen. So that is a mass. So we are going to start here with the mass and go 2 moles of that. When we do that, we need to use the conversion factor of 1 mole equals molar mass. Sorry, Gwen has a question.
Mommy, can I watch you?
I suppose. Okay. Sorry about that. So we are going to start with our given amount. Our given amount is 5.40 grams of hydrogen. Now, my subscripts do not work on this whiteboard, so I'm just going to go ahead and write the big 2 after the hydrogen because it's important for you to remember that there are 2 hydrogens in this chemical equation here. Okay, it's H2. It's not just H. All right, 5.4 grams of hydrogen times, and then we've got to include our conversion factor. We said that our conversion factor for mass to moles is 1 mole over the molar mass. So 1 mole of H2 over Gwen, can you turn that down?
No, sorry.
Then you need to take it into your bedroom. Okay? Okay. The bottom then is where we're going to put our molar mass. So the molar mass of H2, you'll need your periodic table. Hopefully you have hydrogen. Okay, though hydrogen is 1. We have 2 of them. So 1 times 2, 2 grams of hydrogen. So that is our first part of the problem. We are now converted that mass into moles of substance A. Now we need to go from moles of substance A to moles of substance B. So this is what we just did, where we used that mole ratio. Remember the mole ratio, you look at the balanced chemical equation, you figure out which 2 are you comparing. So we are trying to find ammonia, and we have been given hydrogen. So we are comparing hydrogen to ammonia. So it is a 3:2 or 2:3 ratio. We have to decide which one is going to go on top, which one's going to go on bottom, based on our units canceling, right? Units canceling. So if you look here, we want our moles of hydrogen, you want that to be diagonal for it to cancel out. So we want moles of hydrogen to be on the bottom of our next conversion factor or mole ratio or whatever, okay? So we want moles of hydrogen to be on the bottom so that that can cancel out. Our moles of hydrogen and our mole ratio is 3. 3 moles of hydrogen. On the top of that then, we're going to put in our moles of ammonia. Moles of ammonia is 2 in this balanced chemical equation. 2, that big number that's in front of our ammonia. Okay, now we've got our mole ratio, so we just went from substance A to substance B. Now we just need to get substance B converted to mass because the problem asked us for grams of ammonia. Grams of ammonia. If the problem just asked us for moles of ammonia, we could be done. This is not a start to finish process. You could start the process here and end on moles. You could start on moles and end on mass. So don't think of it as just one process start to finish. It can be broken up into two little pieces, which you'll kind of see as you continue on here. So times, and our last conversion factor is moles to molar mass. So if we look here, we have moles of ammonia on the top here. So we're going to want moles of ammonia on the bottom. So we're going to put 1 mole of ammonia because we're converting moles to mass. So it's always with 1 mole. We always compare it to 1 mole. 1 mole of ammonia. And then on the top is what? The molar mass of ammonia, NH3. NH3. So we have 3 H's. So 1 is the mass of hydrogen times 3 is 3, plus the mass of nitrogen is 14. So 14 plus 3, 17 is the molar mass of ammonia. So now, if you type this all into your calculator, you should come up with the answer. So 5.40. 5.40 times 1 divided by 2 times 2 divided by 3 times 17 divided by 1 equals 30.6. 30.6, and our label is grams of ammonia. Woohoo! 1 down, hundreds to go. No, but seriously, guys, if that made sense to you, that is huge. It's huge. You just did a stoichiometry problem from start to finish with every single step possible. This is as hard as it will get right here in terms of just your basic stoichiometry problem. All right, now we haven't gotten to limiting reagents and limiting reactants. For those of you who are ahead of the game, working ahead, those can sometimes get a little bit complicated. But this is your most lengthy stoichiometry problem here, okay? Like I said, where people start to get confused is that you can stop and start this process wherever. And that just depends on what given information you have. So what I'm going to ask you to do to go on and continue investigating this is now look at some of these other options for where you may start and stop this process. So here's one where you're going from mass to moles. So you've been given grams of something, you're going to convert it to moles of that substance, and then you can convert it to moles of the second substance. So you're not going all the way to the end. You're going from mass of one to moles of it, and then to moles of the second substance. You do not do that last piece. All right? And that just depends on what the problem is asking you to find. So this would be an example of that. Here's one where it gives you moles of substance A, and then you go to mass of substance B. So for that one, you would be starting here and going to here. You would be skipping this first conversion factor. So a little bit of critical thinking here, all right? You guys can read through the rest of these slides. It reminds you of some of those other conversion factors that you might come upon here in these last practice problems. That 1 mole is equal to Avogadro's number of representative particles, and 1 mole of gas is equal to 22.4 liters. Here's a slide with all the different conversion factors you can use. Now here is where your assignment for the next time we get together. You need to do sample problem 12.4, which is a mass to molecule conversion. You need to do sample problem 12.5, which is a volume to volume calculation, and you need to do sample problem 12.6, which is another volume to volume calculation, it looks like. So those will be your assignment for the next time that we get together. Now obviously you're going to have lots of more practice with this before we move on. Some of you may be like, I get it, let's go. But most of us are feeling like we need more practice with this before we move on. So I will give you more practice with this, but your job is to just continue through this section, through slide 25, and do some of these other examples. The other options of what if I start with volume and go to volume? What if I start with particles and go to particles? What if I don't start all the way on the left? Those different options of types of problems. Okay?